Right, so this is what we've got here. Problem, the red stuff is RTV silicon, and I think it saved my motherboard. I'm never not putting RTV silicon on every sensitive bit. That is just amazing that all those plugs are still there. After that, seriously, that's just crazy. And then like you get these motherboards from the factory, and some of these soldering bits, they tend to be a little bit weak, especially those ones there, or even the structural joints on the side. Could be due to shipping, or could just be a faulty part they never picked up, but oh, saved my bacon, that one. Anyway, okay, so far I've removed the motherboard, and you can see the RTV silicone. I'll just clean off the bits there that I need to, and I'll reapply a lot more once I'm finished. Protect those juicy small parts, because once they come off, they're a pain to put back on. And I've taken off the outer shell. Now the outer shell, of course, is slightly bent. I'll need to bend that back in. I've got the vise over there, so I'll just vise it around the steel parts, take the components off, and just bend it back in slightly to fix that issue. Yeah, you can see it there. Much better. So, thankfully, most of the electronics are good. And while I'm at it, I'll put some RTV down there, because I don't know why I didn't. That seems like a really... I mean, it's just a light, but I think in principle I should do that. And if there was, I would put some here too for the level sensor. But thankfully I don't have to. I might see if I can fix that. Zip ties seem kind of inefficient, and they might put undue stress on those wires. Not all the time, of course, but if in a situation that like the front casing was bent outwards, like if it was moving along like that and it bent outwards, and there was some filament stuck in there, or the wires were pulling back on the motherboard at the top, and I mean, I feel like that would be a weak point there. So I'll see if I can improve that a little bit. But yeah, case off, and then I've got to tackle this. Okay, just an update. I'm taking the fan off and the extruder off. Now I got a gripe with the 3D printing industry. What's the go? Come on, focus. See these 3D printed socks? Basically useless after the first couple of prints. They split, cause all sorts of grief. Prints catch on them, they rip off the end bits there. Make something better, because this is shit, for lack of a better word. Probably shouldn't use shit, but yeah, it's pretty terrible. That is where the heater cartridge sat. I made sure to put RTV silicon in there between the two, in the hope that it would give it a bit more strength. Yeah, got my acetone clump there. I'm just trying to dissolve it with some acetone. Acetone clump. I've got my ABS clump there, I should say. I'm trying to dissolve a majority of the surface ABS with, or ASA, with acetone. I've just heated the acetone up a little bit to increase the process. And then every now and again I'll scrape off a couple of layers and keep going until we get down to the very, the hot end. A lot of people will say that the wires, you can't use acetone with the wires. In my head, I've got steel and lead wires, which do not dissolve in acetone. Yes, the coating on the wires does. So we've got polypropylene, I think, or some sort of elastic petroleum-based plastic coating the or insulating the wires, and I can get around that by just coating the wires in RTV or the similar sort of silicone coating. It does potentially damage ceramic, so the ceramic heating cartridge, but it needs to be fully submerged, I believe, for that to happen. But we will see the results. I'm sure a lot of people will tell me, oh yeah, nah, it doesn't work, but I'm trying it out anyway, and we're gonna see where we get to. I just wanted to point out that I'm heating acetone below its boiling point, but close to it. I'm not actually boiling the acetone. I'm trying to keep it under its boiling point so it doesn't vaporize and I lose all my acetone for cleaning. I want to just keep it just a bit under and just slowly scrape away the layers. I should also mention that I am doing this in a heated ultrasonic cleaner with a vat full of water. It's important to use the water so that you get an even distribution of heat, and you can slowly increase the heat without any spikes. Cool. So we've got the hot end back on, just reassembled it, everything's together. We always end up with one screw left over. Where'd it go? Anyway, not really sure about that screw. I'm pretty sure, or bolt. I'm pretty sure that that might have come from another unit that I've been working on. But anyway, as far as I can tell, it's all reassembled and all ready to go. I've done a PID tune. Temperature's getting up to 170, 140. Oh, sorry, 240. I've done a PID tune to 260, and everything seems okay. I've leveled the bed, or I'm in the process of leveling the bed. I want to get an eddy or an induction probe, a special one, and from Big Tree Tech, and turn this process into something that takes a couple of seconds rather than like an hour or whatever, because I have to go around and modify all these screws until it reaches zero. Anyway, so in order to do that, you sort of replace the probe in here, that guy there, with either Big Tree Tech eddy or a similar unit, and then you program the firmware code onto Clipper. Process isn't extremely painful. You just have to modify the config file, or main config file, for the Elegoo Giga. And honestly, the firmware they use is not like it's pretty good, like in terms of knowing what components are what. But I flashed it with Clipper version 12.0, and everything worked. The camera worked fine, even some processes really quick. So yeah, the open source Clipper program it can be used with this machine. You just have to fiddle around with the firmware until it works. Yeah, I mean, yeah, and like you need to back up your previous firmware, so if you ever come into a problem, you can flash the original firmware again, and you get it back to factory settings and start again. Like I've had to do that once, and like I could have just reinstalled Clipper and done it a longer way, but Elegoo had already compiled firmware and exported it out to a flash drive that the printer will see when it starts up, and just load the firmware. So yeah, best to have a backup USB in case you brick the motherboard, but it's not all is lost. It's definitely repairable. So yeah, just gotta know how to do it and have some patience. Yeah, that's been my repair of an Elegoo hot end. Thanks.